Hi, every student. The class starting. You must go to the teacher's website. The application of Python artificial intelligence in business forecasting. And you must to open the chapter 5. This is the simple 3 steps programming. I'm sorry, close the chapter 5, open the chapter 6. This is a beginner 6-step programming. And today I want to do the example 6-1. Okay, now here we have 5 steps for the linear regression. This is the 5 step. And first of all, that we should to read the data. But we must read the data, the train data. We have two data set. One is training data set. The other is testing data set. This is DF train. This is DF test. So first of all, we want to read the data of DF train. Okay, we insert the cell and we import. We should connect to the server first. And we read the file to the DF train. We use the PD read Excel. And we need to have 2 parameters. These 2 parameters, the worksheet is 黄金对美元. And the file of that is this. And after I read of this, okay, after I read of this, I to show the trend of this. HTTPS, the file of this, okay, this is not correct, right? So, and the same that a copy of this, and I will, okay, and then I, here this is my DF trend, and I want to get the value of the X trend and the Y trend. So we get the value of X trend. That is from the DF trend for the 美元. That is the DF trend. And we also have a Y trend. That is DF trend for the just only one dimension of 美元黄金. And then I show the S trend. This is the 美元. And then here that is I test the data set of the okay, this is the data set, and the Excel file is for this, and that data sheet is 测试. So the file of this that I should, I think the file is the same, but it have a different data table, data sheet. Here this is test data, and I read of this to the DF test. And for this is 美元 and 黄金 data, right? But this is only for test. And here this is for the train data. And now I want to practice the five steps of AI. First is build a mathematical model. So I want to build a linear regression algorithm. Scikit-learn for linear regression. I call this as linear regression model, linear model. And I build a model from an algorithm called the linear regression here. Then I have built my model now. And then I want to train the model using the historical data. I insert a code cell. I use the model to fit. And the fed data that is I use train data to train that. Train data for Y train. Then I have trained the data. Use X train and Y train. And now I want make the prediction when US dollars is 29.775. So what is the gold price? Okay, so now I want to make the prediction. Here is a two-dimensional, right? 29.75. So okay, but we also have the second kind of variety that is more clear than this way. Because this is I must use the vertical types of the data frame. So I should import and I do the model predict. I use the PD data frame and I transform 2975 to the vertical types of the data set. Then I can get the same result, 1649. That is the gold price. And here we have a question. Why do we split DF into two datasets, DF and DF test? And why and how do we do this? Why we do this? The reason is the use of the DF test to evaluate how good or accurate of the model is, and to check whether overfitting has occurred. Conclusion 1. Use DF train to train. Use DF test to evaluate the model accuracy. So now how to quantitatively evaluate the performance of a linear regression model. Is the model accurate? There are two quantitative measures, MSE, MAE error, or R square. R square, this is also called coefficient of determination. So we have two methods. Now we practice the first method, that's MAE, MSE, to evaluate this model performance. So because this is the MAE, MSE just inside the matrix, and we use this matrix, we have a function called mean square error. And here we should input the Y test and the Y prediction to calculate the mean square error or mean absolute error. So now here I want to represent how good of model is, I use the arrow of MSE. So now I use the import scikit-learn. We have the matrix. I call this as MATS. And now I want to do what? I use the MTS to select one algorithm of the MSE and mean square error. Here this is a function, right? But for the function that it must to input the y true, the raw data of the y, and also the y predict, the predicted data of y. So first I know the y data that is y test. But now I want to also to use of the y test to have the y predict. And how could I to calculate the y predict? I use the model predict. The predict I must to input the x, right? Here x that is a multi-dimensional data. So I put over here that is the I must to do the okay. I use S test to predict y. So and then finally I can calculate that of S test is not defined. So since that I should have the S test. Here is my okay S 下引线 test. So yes, this is 下引线 test, right? So why that the answer is not correct? Okay, after I do this, I also should have the S test is df test two-dimensional 美元 and also for the y test df 下引线 test for the 美元黄金 and then I can do of that. Finally, because I have access right, so now I can do that. I have the data of S test. So here the error is like this, the same. And then we have the second kind. Oh, okay, this is MAE. Uh, because the matrix algorithm, we also have the mean absolute error. So if I just copy of the code of here and I write of the other kind, I do not use the mean square error. I use the mean absolute error. So the answer is quite the same. But because this is square, so the value will bigger. This will smaller, just because that is absolute value. Okay, here this is first kind of matrix to evaluate how accuracy of a model is. Here is the second method to evaluate how to evaluate model performance. The method 2 use the R square. It's also called the coefficient of determination. Okay, let me do this. And for this R square, we have two kinds of methods. The first is I use the model dot score. This score will give the score for this model. And here you should input S and Y. X is the two-dimensional, right? So here that is a test, right? X test. And that is Y test. So this model accuracy is the 0.6. And why is this mean? It means evaluate the strength of the linear relationship of the model, i.e., that is linear accuracy. So here have the 0.6 linear accuracy for a line. If just a line, that the value will be 1. And calculate the model accuracy, the second method is using the matrix performance indicator R square score. So I do this again. Here that I should input the scikit-learn. It have the matrix. I call this MTS. Inside the MTS, I have a algorithm. The algorithm is called R square R. Okay, the first one R square, the first one R square. And inside the R square, you see you should input the R true. It means the raw Y value and the Y predict value. My Y is Y test value, and then my predict letter is Y predict, right? But I should to do the predict Y predict first. That is, I use the model dot predict, and I use X test to predict the Y. Finally, the answer is also the same with the score. The R squared score the same with the score. The value is the same, is the 0.6. And then I want to do the last step, step 5. Test whether the model is overfitting. And the overfitting means that you see we have the train sample and test sample, right? For this color, the clothes, the blue close symbol. Here that is the data that I train. You will find, and also the line here, this line, the blue line, here is my prediction. The I learn the data and predict the data, and this the dash line that is the low sample, low value, and you find for the red color that is test sample, right? You have a bit error due to your prediction and the low data have a gap. But for my train data, he will then have a smaller error. The test sample have a bigger error. So I have a high score of the train for the accuracy of the model. But for the test sample, I have a smaller accuracy. So this kind of phenomena, we call it as overfitting. It means the train data is correct, but the test data is not correct. So I want to check that in this example, for the do I have the overfitting phenomena? I want to test. So you see here, if score train is very high, the score test is very low. It means it indicates that overfitting has occurred. So now I want to do of that is okay. Here that I insert of that, I show the score of train data. I use model to give me my score, score. Here that I input the S train and the Y train. It tells me the score. Your score is 0.53. And I also have the other one that is score of test data. Then for the test data, the score of the model is the S test and the Y test. Okay, the score is 0.6. So, okay. And then now I do the conclusion. Because the score of train is smaller than score of test. It indicates that there is no overfitting happen. And here that is the step 6. I want to do the quantitatively check the correlation between each feature column. Today we have two columns, right? X and Y. Feature column and the target and the label column, Y, right? So I want to show the US dollars and the gold. For this parameter, the relationship parameter coefficient is how much? And I use the, okay, here that I insert. First of all, for the, this is the coefficient, right? Coefficient for what? For trend data. I use DF trend to use this of that and use the coefficient. And finally, I can get, you see that here, if the US dollars is 1, the, the gold have a negative parameter with it. So here that I can show the conclusion. When US dollars is 1, the gold it will be negative 0.773. That is a negative effect. And here this is a, I can say that is a strong negative coefficient. It means that both of the, okay, this is moderate, not very strong. The moderate. So it means this parameter they have moderate coefficient, negative correlation, moderate negative correlation. Here this is for the trend data, right? But if I use the other one, the correlation for the test data, I use the test data test to do the coefficient. The answer is, if, okay, it indicates that when the US dollar is 1, the gold will be what? Negative 0.91. It indicates they have the strong negative correlation. They have the strong negative correlation. Okay, student, you have the 5 minutes to practice by yourself.